Hey everybody, so this is Mr. Walker, and in this video I'm going to show you how to simplify radicals, but I'm going to show you a little shortcut that you will see in some of the problems, and this shortcut will greatly speed up the process of simplifying radicals. So right here I have a problem. It's the square root of 128. And for just a second, ignore this. We will get to this in just a second. Just focus your attention on this problem right here. Square root of 128. First thing I notice when I look at a square root of 128 is that that number's even. And I know that because the last number is even. So I know that 2 will go into 128. So I'm going to start breaking this down into factors. And this was in a previous video, how to use a factor tree to simplify these radicals. So I know that 2 will go into 128. And it goes into 128 64 times. So 2 and 64 are factors of 128. And you know that because 2 times 64 is 128. And now if I look at my 64, it's also even. So I know that 2 goes into 64. So I go 2. 2 times what is 64? 2 times 32 is 64. And I keep doing that process. That is even. So 2 times what is 32? 2 times 16. 16 is even. So I have 2. 2 times what is 16? 2 times 8. 8 is even. 2 times what is 8? 4. And finally, 4 is even. So 2 times what is 4? 2 times 2. Once you have all the numbers broken down to a prime, and 2 is a prime, you can stop. There's nothing else to be broken down. And then what you do is you circle your pairs. So right here I have a pair of 2's. Now I circle another pair. Right here I have a pair of 2's. And I circle another pair. Right here, I have a pair of 2's. And then, once you've circled all of your pairs of primes, you can start pulling them out. Here's what I mean. That is a pair of 2's. I can pull one of those 2's out. And what I mean is I can write a 2 outside of my radical. So when I say I can pull a 2 out, that's what I'm saying. I can pull it outside the radical. Once I pull one of these 2's out, I have dealt with both of them. And the reason we do that, by the way, is because if you look at this, 2 times 2 is 4. And what is the square root of 4? 2. So that's why I'm bringing that 2 outside of my radical. And then here's another pair of 2's. I take one of them and I pull it outside of the radical. So I have times 2. Once I pulled one of them out, I've dealt both of them. And then right here, I have another pair of 2's. I take one of them, I pull it out. Once I pull one of them out, I have dealt with both of them. And finally, I ask myself, what's left over? Just that final 2. And that's what goes under my radical, because I can't pull it out. It doesn't have a pair. And remember, when you're pulling stuff out, you're only concerned with the end of your tree. So all these numbers right here, they're in the middle of your tree. I don't care about those anymore. I only care about these numbers. And finally, we're almost there. Right here, that can be simplified. 2 times 2 is 4. 4 times 2 is 8. So 2 times 2 times 2, that is 8 square root of 2. Okay? And that is the simplification of that radical. But there's a quicker way to do this, and that's kind of the whole point of this video. When I have a square root of 128, I'm going to start out the same. I'm going to say, well, this is even, so I know that 2, and let me go ahead and change my color. So I know that 2 will go into it. 2 times what is 128? 2 times 64. But right here, and this is the absolute key to this shortcut, you can stop. You can stop right here, because look at this 64. There's something special about that number right there. It is a perfect square. So now direct your attention over here. See that 64? 64 equals 8 squared. 64 is equal to 8 times 8. So I can actually break that 64 down to 8 times 8. We call those perfect squares when they have a factor that is 2 integers multiplied by each other. 8 times 8 is 64. And I have a pair. I don't have to break it down any further. As soon as you see a pair, you can stop. So I can circle my 8. And what I say, once you have a pair, bring one of them outside of your radical. Once you bring one of them out, they're both dealt with. And what's left over? That 2. And look, this answer is the same as this answer. It's just that this was a much quicker process. So the key is, when you're breaking these radicals down into their primes, if you ever run into any of these numbers, you can stop. You can be like, well, let's say you run into 49. You can be like, wait, I know 49 is a perfect square. I know 49 is 7 times 7. And I have my pair. I have a pair of 7s. Therefore, I can pull out one of my 7s. And that really speeds up the process. So real quick, I want to work out one more problem. Go to the next slide. And I'm going to do, well, you know what? I'm going to go back to my previous slide. And I'm going to erase all this for a second. And we are going to do the square root of 288. Okay? So I look at this and I'm like, well, this is even. I know this is even because the last number is even. So I know 2 will go into it. 2 times what is 288? 2 times 144. But then I think to myself, I recognize 144 as a perfect square. Look over at our table. 144 equals 12 squared. 144 equals 12 times 12. So I can break that 144 into 12 times 12, and there's my pair. I can circle it. And I can be like, well, I got a pair of 12s. I'm going to bring one of my 12s outside of my radical. Once I pull one of the 12s outside of the radical, I've dealt with both of my 12s. And finally, what's left over? Just this 2. So right there. And that is your answer. So you can't always use this shortcut, but you very often can. Whenever you see one of these numbers in your factor tree, you can stop, you can break it down into this number, and then you can pull out that number, because that will be your pair. Right? It really speeds things up, and I think you'll find it very useful. All right. Talk to y'all later.